Hi, everyone. Welcome to the Secure Stage Quarterly Strategy Review. I'm Sarah Waldner, the Group Manager for the Secure Stage. This is my obligatory notice that this presentation and linked pages contain information related to upcoming products, features, and functionality. It's important to note that the information presented is for informational purposes only. Please do not rely on this information for purchasing or planning purposes. As with all projects, the items mentioned in this presentation and linked pages are subject to change or delay. The development, release, and timing of any products, features, or functionality remain at the sole discretion of GitLab. I want to introduce you to the team. So the Secure Stage consists of the Static Analysis Group, led by Connor Gilbert, the Dynamic Analysis Group, led by Sarah Meadsinger, and the Composition Analysis Group, led by John Crowley. We also work closely with the Vulnerability Research Team. All right, a little bit on strategy. So at a high level, our stage plays in 3 different markets. We directly target the application security testing market and offer a comprehensive suite of security scanners designed for AppSec. We serve the governance, risk, and compliance market as well as the advanced security orchestration and correlation markets partially. As of today, we aim to solve many of the problems personas for those tools face, but not all of them. As an example, today we do not offer correlation between vulnerabilities, but do plan to offer that in the future as we mature our offering. Our product offering sits at the intersection of those 3 markets, and as a result, serve 5 different team personas, all working together towards a common goal: secure software shipped fast. Today, we meet some of the needs for each team. Our product strategy at a high level is to focus on providing a streamlined experience that solves the problems highlighted in the overlaps between the teams as our main value proposition, being a single application that enables collaboration at the interfaces between different functions. The roadmap for the Secure Stage as a whole is organized into the following themes that you'll see each group touch on. These reflect how we are addressing the needs of the market strategically. We need to streamline getting started for our security scanners. This means creating a delightful onboarding experience and ensuring as much as possible is on or set up by default. This also means making sure that we are locating each type of testing in the right place in the development process, as far left as we can go. For our second theme, moreover, when appropriate, we are decoupling scanning and continuous integration, as we are doing, for example, with continuous vulnerability scanning. Finally, we know that security is a team effort, and companies are most successful when development and AppSec teams are working together in lockstep. Security testing should happen early and often as possible to make shipped code as secure as possible. And this happens when security is approachable and developers are empowered to understand and remediate security issues without direct manual intervention from a security professional. Within our roadmap, we can bucket our value creation opportunities into short and long term. Immediately, we know that we need to be improving our SaaS and software composition analysis scanning capabilities. These are among the first to be evaluated, and our performance in these areas has an outsized impact on the success or failure of a deal. We're also focused on bringing security scan results even earlier left in the developer's workflow, as this represents our main value proposition. Longer term, as we steadily mature our security offering, we will work to expand our product to surface risks beyond vulnerabilities and create a robust experience in which developers can fully self-serve in terms of prioritizing which vulnerabilities to fix and in what order. We will also leverage machine learning and AI to enhance the productivity of both developers and security teams. All right, on to group updates and plans. I'm going to go ahead and cover the recent highlights and roadmap for static analysis in Connor's absence. Okay, so to start and just give a little bit of framing to how we're developing our static analysis software testing roadmap. So the priorities we're pursuing here respond squarely to what our customers and the market tell us they need now and as they continue to shift left. Our 3-year roadmap focuses on the ultimate tier, the offering that organizations select when they're looking to uplevel in security. It's our fastest growing tier due to our security product suite. Planned improvements will solve key problems that organizations face when starting with a new security tool, such as onboarding and adoption, and we will continue to lead into our biggest differentiator as a comprehensive DevSecOps platform that allows us to streamline the integration of security tasks into developer workflows. We have intentionally designed our roadmap around the following 4 themes that I'll reference as I walk through the highlights that we've recently shipped in the roadmap. We'll be improving We'll be improving detection efficacy via short and long-term strategic investments across the stack by enhancing detection engines, rules, and related technologies. We're laser focused on advancing the developer experience, as we know this is key to speeding up triage and remediation of weaknesses because security outcomes are better and cycle times are faster when developers and security teams share responsibilities. We're actively investing in strategic differentiators such as AI, and we are enabling more tailored policy control and enforcement. These efforts are supported by every product team at GitLab as we invest across the stack to bring security everywhere. Okay, on to highlights. Static analysis team has been busy over the last few months since our previous quarterly update. I'll cover a few highlights across the board. We've made continual improvements to advanced vulnerability tracking, including adding support for anonymous functions and adding PHP language support. We worked on refactoring exclusion logic and our SemGrep analyzer to increase extensibility when choosing what rules to run or not. We optimized a query timeout issue that will allow us to make progress on releasing many more rule removals, and we released the first iteration of displaying security pipeline findings in the VS Code editor. In addition, the team has been working very hard on 2 other projects that are not directly customer-facing yet. First, we developed a proof of concept for pre-receive secret detection. This is an exciting milestone for the team. The demo is linked here in the side for your consumption. We also created an internal tool that enables the static analysis team to benchmark and test changes to analyzer rule sets. This previously had been a huge blind spot and the cause of many customer complaints and escalations. Having this testing infrastructure in place improves rule quality and team efficiency, as the entire process can be executed with just a few clicks. And finally, we wrote a runbook for monitoring SAST vulnerability auto-resolution, which will help with releasing rule improvements in a more efficient and safe manner. Okay, moving on. A little peek at our 12-month roadmap. We've made some updates that I'm excited to share. So immediately, the team is working on, in Q4, we'll continue to make progress towards reducing false positive findings by removing low value and low efficacy SAST rules. Our aim is to wrap up this effort this quarter. We'll complete 1 to 2 additional SemGrep conversions for Node.js and Brakeman scanners specifically. We're going to continue to shift left with work on surfacing security pipeline results in VS Code, moving beyond the first iteration that we recently released. And we have the goal to ship the experimental release of pre-received secret detection. Finally, we'll be wrapping up UX improvements for showing SAST results in the MR Changes tab. Moving into Q1 of next year, we plan on releasing end-to-end coverage for Go in our proprietary SAST scanner vet. We intend to mature pre-received secret detection to beta. We will be completing our migration to SemGrep with PHP, MobSF, and Spotbugs conversions, and improving the efficacy of SemGrep rules by enhancing detection logic for existing rules and adding brand new rules. Moving into Q2. We plan on creating logic that helps to improve prioritization of secret detection results. We'll be working to extend VET to provide end-to-end coverage for the Ruby programming language. We'll be improving the efficacy of our SemGrep rules by updating severities and adding important metadata for the rules. And finally, in Q3, we plan to be working on integrating static analysis findings in new places throughout the platform to improve the user experience. We intend to have an early release of secret detection outside of CI/CD pipelines and a POC for real-time SAST scanning in the IDE. All right, that wraps it up for static analysis. I'm going to hand it over to John Crowley to cover software composition analysis.
Thanks, Sarah. All right, so just to jump in here to talk about some of our recently released features. So we have released the experimental version of continuous vulnerability scanning for dependency scanning. Next up, we have also released private registry support for operational container scanning. Both of those are in 16.4. In terms of the 12-month roadmap, so just to recap before I jump in, composition analysis is made up of dependency scanning, license scanning, and container scanning. For the composition analysis 12-month roadmap, we have a high degree of confidence in the near-term initiatives, while the work items farther out in the future may shift based off of customer needs and ongoing work. But to jump in the November through January period, we had three main areas of focus. So the first one up is GAing continuous vulnerability scanning for dependency scanning. So a little background here, the dependency scan runs and an SBOM is generated. This contains all of the dependencies associated with a project. We match the SBOM artifact with GitLab advisory database to provide the vulnerabilities for a given project. The GitLab advisory database is fluid and is changing daily with new vulnerabilities that are disclosed. Continuous vulnerability scanning replaces the need to run scheduled scans or rescanning your project to get new vulnerability information. It's going to allow users to get information more quickly in a more streamlined way. This is experimental and it is currently live. We have some additional work to do to consider this feature GA, and that will be our focus in the November through January period. Moving on to our second initiative, once we GA our release for continuous vulnerability scanning for dependency scanning, we will work to extend the same functionality for container scanning. The benefits are the same. We will get threat data more quickly and remove the need to rerun your projects through a pipeline. The last item in this period is identifying if a finding is fixable in container scanning. We've identified that some vulnerabilities surfaced by container scanning cannot be fixed, which can be attributed to vendors not having released a patch. This feature is going to reduce noise, as users will be able to hide or ignore vulnerabilities that fall into this category of not being fixable. For the February through April period, we will be focused on continuous vulnerability scanning for all GitLab container registry images. Images will be stored in a container registry and it will be scanned by default. Findings will appear on a new tab on the vuln page as well as the registry page itself. Next up here, continuing to mature our continuous scanning for dependency and container scanning. So the goal here is after these have been GA'd, we will hopefully mature these based off of feedback from customers and some internal evaluations. Last item in this period is Android support for dependency scanning. So there's high demand from customers for this, and it's on the top of our list to try and increase our scanner coverage, which is very important for us. In the May through July period, we're going to be improving our dependency scanner coverage for Python and Java. There's a number of improvements that we've identified in terms of how our dependency scanner works with these languages. So we want to implement those changes that we've outlined. The next item is particularly exciting. We will be focused on improving our risk-based vulnerability prioritization through EPSS and KEV data. So EPSS is a scoring system that's going to highlight the likelihood of vulnerability being exploited in the wild. And KEV is the known exploitable vulnerability catalog, and that's going to alert users to vulnerabilities that have already been exploited. The goal with these new data points is to reduce some of the noise that it's attributed to simply driving remediation efforts based off of severity. This should help users more effectively prioritize the vulnerabilities that they want to remediate and those that can be ignored based off of internal threat models. And in the last period of August through October, we're going to improve auto remediation. There was some initial functionality built around this, but there are some enhancements that will better support our end users. Hopefully, our goal is to roll out functionality that is essentially where an MR is automatically created within the patch. And that wraps it up for composition analysis.
Thanks, John. I'm Sarah Meadsinger. I'm going to cover dynamic analysis. So in 16.3, we released runner tags for on-demand DAST scans. On-demand DAST scans run outside of the DevOps lifecycle, and they're either started manually or scheduled to run. They're primarily run by security teams rather than developers, and we've gotten feedback that our security teams often want to configure things via the UI rather than YAML files. So we've given them the ability to choose exactly which runners are being used for on-demand DAST jobs while still being able to use generic runners for all other jobs. In 16.4 and 16.5, we've also released 5 browser-based DAST active checks. These are proprietary checks that provide parity with Zap functionality and help power our proxy-based DAST offering. So you don't have to take any action to benefit from these new checks. As we release one, we enable the new check, and then we simultaneously disable the Zap check. Coming up on our 12-month roadmap, we're continuing to focus on our browser-based DAST offering, which is built completely in-house and enables us to more effectively crawl modern web applications. So it's especially important for single-page web apps that heavily use JavaScript. And this will allow us to provide greater coverage of your web applications. So we've already implemented proprietary passive checks, which identify vulnerabilities in HTTP messages. And as we just discussed, we've already started adding some active checks, which inject payloads in HTTP requests. So we're currently adding additional active checks from November through January, primarily focused on match response rules, timing rules, and cross-site scripting rules. And then in early 2024, we'll continue that work and focus on files and directories that are exposed and session fixation. And once we've wrapped that up, we are going to migrate our on-demand DAST scans from our proxy-based DAST offering or our Zap-based offering to our browser-based DAST offering. And that will enable us to remove Zap and remove our proxy-based DAST offering at the 17.0 release in May. This will help us unify our DAST offerings and simplify security scanning, which is one of our major goals. After that, we have some DAST authentication improvements we want to make. We know that authentication is one area that a lot of customers run into difficulty with, and in general, DAST offerings are often considered difficult to configure and can fail kind of just at the authentication phase. So we plan to add a lot more granularity there to help ensure that it's easier to onboard. We also want to continue to simplify onboarding for DAST API via API discovery. So we'll automatically generate API specifications so that customers no longer have to provide those themselves in order to use our offering. And then after that, we will create a callback service in Q4 of next year, which will help us add more complex checks to both our browser-based DAST offering and our DAST API offering.
All right, thank you so much. Please join us for the live session to do questions and answers.